Hello there, welcome to question 8 of our examination preparation series for paper 1. In this question we'll be interacting with the parabola, sketching it as well as talking about nature of roots. There is an interesting question in question 8b that will definitely expose a lot of things, and I look forward to presenting that one. Okay, in the meantime, let's take a look at question A. Alright, so the question is asking you to explain why this equation has no real solutions. In other words, is there a real number that we can substitute here for x such that this equation is true? Definitely not. That number does not exist. Why? Because if you take any number, in this case it is described as 2x minus 1 and you square it, you're going to end up with a negative or a positive quantity. Positive one. Okay, so that is the reason. Because 2x minus 1, it's always greater or equal to 0, can never be a negative number. So therefore the solutions for this equation can never be real. Okay, that is an easy 1 mark explanation. Great stuff. Alternatively, you can find the discriminant and obviously transpose the -5 and find what that discriminant is, and we'll see definitely that it will be less than 0, and therefore the roots will be non-real. Okay, good stuff. Let us look at question A2. A2, we are asked to sketch the graph here, and the equation is given as 2x minus 1 all squared, okay, plus 5. So we have y equal to 2x minus 1 squared plus 5. So this is already in turning point format. Can we read off the turning point coordinates here? We know that the y coordinate will be 5 and the x coordinate will be what? 1 over 2, right? So that is where you find the coordinates of the turning point. No calculation needed, it's totally unnecessary. It's a read off question. So we have taken care of that. What else do we need? The y-intercept. What is happening here? X equal to 0. So the y-intercept will be 2 times 0 minus 1 all squared plus 5. What does that give us? It gives us 6. Okay, y-intercept is 0 and 6. Okay, are we ready to sketch? Yes. So just gonna create Cartesian plane here. Okay, and call that 1, 2. Okay, so we need 1 over 2. And 1, 2, 3, 4, 5, 6, 7. Okay. So right here at 1 over 2, let's coordinate there. It's 1 over 2. It corresponds with the y coordinate of 5. So that is the turning point. And concavity definitely is concave up. Okay. And what else do we need? The y-intercept at 6. Okay, the turning point, remember, it's where the symmetry line passes, so definitely we can predict that the other side of the graph will look like that. Okay, so that takes care of the sketch. Doesn't make contact with the x-axis, which speaks to the first question that definitely there are no real roots for this equation. So this is the full sketch for question 8A2. Okay, so let us move on now to question 8A3 and look at what's happening there. Take a look. Okay, so in this question we are asked to talk about the transformation of the function and how can we move this graph vertically such that the roots will be real and also equal. What does that mean about the discriminant? discriminant must be equal to 0. So you have one double root there. Okay, or you can say two equal roots. Okay, we know that the turning point there is 5. So the vertical distance here is 5 units. If we take this all the way to the x-axis, and obviously the y-intercept will also move down to what? 1, right? Look at how the new graph will be. You're not asked to sketch it, I'm just giving you a visual representation of the solution here. Okay, so that is the new graph. It will definitely have real and equal roots because definitely the discriminant will be equal to 0 in this situation. So therefore, how must we move it? 5 units down. So the answer to this question is 5 units down. Okay, or we can just say, yeah, it's fine, 5 units down. Okay, so this takes care of the first half of question 8. In the next video, I'll talk about the second half of this interesting question. Okay, so thank you very much for tuning in. Be on the lookout then for the next video. See you next time. Sharp, sharp.